the topic of the presentation is solution for the carbon neutral pulp and paper production. And in this, we are going to talk about the model and optimization driven approach through ESD tool. And it works in collaboration with energy expert and the process experts. And it is addressing the topic of trust, which was raised during the inaugural session. So if something is driven by technology, so the trust automatically comes on the results and insights coming out of the technology. So first of all, I would like to discuss on the current global energy scenario, where the current electricity generation, which is increasing at a rate of about 2 to 4% CAGR till 2050 and afterward, and considering the various places, stated policies, sustainable development and net zero targets, as per the stated policies which were stated by UN body and various governments, to reach the carbon neutrality, the mix of various energy conversion sources, they should change at a very faster pace. So the fossil fuel to renewable sources, there the change should happen in a faster way. Like if by 2030, if we want to reach net zero, so in that case, the renewable contribution to the total energy landscape, it should be around 74%, and the fossil contribution should go down to 9%. And similarly, in the if the target is to achieve the net zero by 2040 or 2050, so depending on the energy demand, the share of the renewable contribution will it need to grow significantly. And in this growth by 2030, we talk, so the wind energy, it is for achieve the stated policy aspect. So the wind installation should grow by around 120%, and for net zero, it should grow by around 250%, double of what to achieve the stated policy targets. And in the same way, the photovoltaic power generation, it should also grow by 240% and 500% for stated policy and net zero scenarios. So currently the global mix of the energy, that landscape will also change, and the end-use technologies will also have to change to adapt to that, the changing scenario of the energy transition. So coming to the fiber industry, globally, it is fourth most energy-intensive industry, and in India, it is sixth most energy-intensive energy-intensive industry, and it is contributing about 2% of the total greenhouse gas emission coming out of the four main sources, four main production segments like pulp mill, board mill, tissue and specialty paper, and green solutions beyond pulp and paper production. And these emissions are coming from three routes. First is the direct emission, second is the transportation, what we are using in the industry, and the third is purchased electricity. So the control of the technology supplier to the industry and the industry itself is more on the direct emission, and that's where the industry and technology supplier both are focusing in order to reduce the carbon emission. And these emissions reduction is happening in four heads mainly. So one is through energy efficiency increase, which was talked about in the previous sessions as well. Then by fuel shift, demand side flexibility, and emerging and breakthrough technologies. So there are use cases on the energy efficiency also. So where around 30% decarbonization journey target is, that contribution is coming from the efficiency increase. And in the efficiency increase, various components of the energy conversion, transportation, and utilization, they are getting changed. Like, for example, in case of, in the first session, like motor, they are changed to high efficient motors. In the same way, turbines are changed to high efficient turbines. And other energy sources, which like solar or wind, they are getting added into the energy scheme of the plant. Then in the fuel shift, the low carbon boiler like multi-fuel or biogas or electric e-boilers, they are getting introduced in the system. And similarly, the combined heat and power plants with flex fuel, that is, that kind of turbines are getting added. And it is mostly happening in the European economies. And there, the turbines which are getting introduced, gas-fired turbines, they are 100% hydrogen fire ready now. With, but right now the mixing of hydrogen is at some percentage along with the gases. In the same way, waste incineration, that is also happening in order to reduce, in order to tackle the waste scenario and get the wealth out of that waste in the way of generation of the energy. In the demand side, flexibility, based on the operational need of the plant, like if production is reducing or increasing or grade changes. So based on that, the back end change in the total electricity generation and mix, that is also taking place. And for the peak saving, the energy storage devices are getting, that component is also getting considered in the plant. And such developments are happening in, like in RGE, Indonesia. So this energy system design tool-driven approach was adopted to implement this strategy. In the same way, this carbon capture, that also we can do, and that carbon capture along with the in-house hydrogen production using the green energy, and subsequently the captured carbon and the hydrogen, with the help of that, the e-methanol production is happening, which is getting used in the marine sector as a fuel. So this integration is happening in the pulp and paper industry, and these kind of projects are piloted in the paper industry first. So they are most suitable for the paper industry. Now, when we are going to implement the ESD, there are many challenges which comes in the way, because we are going to deal with multiple energy sources like renewable, fossil fuel-based, photovoltaic, hydrogen-based, and also the transmission technologies are also changing accordingly. Then storage and use of that energy, for that the technology is also changing rapidly. And these changes are bringing a lot of challenges in terms of capital expenditure, operational expenditure, then efficiency, like what kind of efficiency we are looking. And there are many limitations are also coming with these changes, because each and every, like in case of solar, the cyclicity that comes into picture, like in daytime you get that solar power, but in night it is not available. In the case of wind, it is also not available everywhere, and also the intensity of wind that varies across the day. So how we are going to handle those limitations along with the legal and other political limitations at the plant location. And these kind of cyclicity is also going to bring out challenge of availability of the power 24/7. So how we are going to ensure the availability of power 24/7? And from day one, we cannot think about just net zero, because it will require a lot of investment on the technology part, and that is not sustainable from day one. So we have to prepare targets where we decide on the decarbonization journey, where we can set goal that by this year we will reduce this much percentage, by this year we will reduce 30%, and by this year we will go to net zero scenario. And these targets are taken in line with the sustainable production requirements. The capacity of the various power elements, that is also selected accordingly. That is also a challenge. So how the selection, like if I am going with 3 power conversion sources, so what will be the mix of those power conversion sources? What will be the capacity of those power conversion sources? So that is also a big challenge. That decision also need to be considered. And what kind of alternative we are considering in a particular plant. So this is the energy system design's basic concept, where it is a model and optimization driven tool which works in collaboration with the energy expert and the process expert, like experts from the plant, and their input is taken, like all the site-specific data is collected, like what kind of price variation is there. Suppose if I am going to prepare the energy system design for 20% or 100% carbon dioxide reduction in a 10-year time frame, so in 10-year time frame for the various fuel, what will be the price variation? Then what will be the primary energy mix? Then what will be the load profile of various power sources? What will be the load profile of the plant? Then what will be the commodity prices? So that already covered. Then out of that mix, how much fossil generation will be there, and how much renewable based generation will be there. Then ecological conditions are also taken into consideration, and the pre-selection of the technology is done based on the expert advice and the plant management advice. So based on this data, and also and the cost of the various key components selected, and the performance models which are decided, and for that what kind of KPIs are decided, this tool selects the right set of the power generation and conversion equipments. This tool does the sizing of those right set of the equipments, and accordingly how the mix of energy which is getting used from these sources, that will vary throughout the its operation. That is also taken into consideration. And after all kind of optimization, the input what we get is the right selection of the technology with the right capacity, and the optimal operational mix and the ecological and economical part, that is also taken care. So this is the typical, model where all kind of energy sources, I am showing that it can be there. So in a plant, maybe 30% of these energy sources can be there, or in a plant maybe 100%, or in a plant it may be possible that only few energy sources are there. But this model is applicable to all sizes of the plant. So the approach of applying this energy system design tool is the first to understand load and boundary condition. Then in the second stage, the compilation of the technological data is taken care. In the third step, the optimal selection and sizing of the technology is done, as I explained earlier. Then in the fourth step, various scenarios are getting analyzed in the tool itself. And then you are coming out with the right selection of the optimal technology. And in the final step, all kind of ESD, suppose there are 3 design scenarios, so all the 3 design scenarios are considered, and then final optimal sizing and selection is done. So these are the steps, I am skipping it. And this is one use case which is implemented on a recycled fiber-based paper plant in Germany. So here you see only 2 power sources there. One is natural gas and one is grid electricity. And based on that, the energy system was designed in order to get the maximum benefit in terms of carbon footprint reduction and energy optimization. And this is a complex plant where similar strategy is adopted. And the scenarios I am talking where, I will take just a couple of minutes. Yeah, so the scenarios which I am talking, where suppose in case of European market, during this Ukraine war, the gas availability was less, the price was very high. So that was a shock scenario, and in that case, how the emission targets are impacting the overall production cost. So it will become non-sustainable. So various scenarios are prepared. Based on those scenarios, the optimal energy system designs are considered, and out of that, considering the reference values, the best energy system design is considered for the plant. So with the implementation of this kind of a strategy, the total investment in the project, that is reduced by around 16.3%. Total expenditure on capex and opex, 16.4%.
Can you sum up?
Yeah, I'm summing up, sir. So carbon dioxide emission, that was reduced by around 11.6%. And in case this was in the net zero scenario, in case if it is at 25% emission reduction, so in that case it was around, TOTEX was around 16.3% reduction. So this is a carbon emission reduction journey for the net zero target. This is planned for a Scandinavian integrated pulp and paper mill, where the various milestones, timelines are decided, and based on that, which kind of component will be selected, that is considered. Thank you, sir. Thank you, IPTA, for providing us opportunity to present this wonderful topic.